Hey everybody, it's Wojo. Sorry I'm not there to help you out, but I'm hoping that this video will help you complete your work today. I'm at the Muskegon ISD, and I don't want to lose a day, so that way you guys can keep working, we can keep working on this, and make sure we're good. We're going to look at 3 examples of putting the 2 ideas of factoring that we've been doing over the last couple days together into one kind of problem. And so we're going to look at a problem today. And again, I recommend having your notes out so you have this copy in your notes. But we're going to be looking at factoring still. And so again, just kind of take notes like normal. It's a little strange to take notes from a video, but still do it the same way. We're going to look at factoring a problem 2a squared plus 2a minus 112. And up to this point, we've talked about 2 types of factoring. We've talked about factor x's and GCFs. And we're going to basically do both of those in one problem today. You always want to first start off by looking to see, is there a common factor shared between these parts? And so in this problem, there definitely is a common factor because all 3 of these numbers are even. I know that 2 can be divided out of all of those pieces. So I'm going to take a 2 out front, and then I'm going to say there's no a's that they share, because this has 2, this has 1a, and there's no a's there. And so 2 is our common factor, and so we're just going to say 2 times what would get me back to all of this. And so 2 times a squared would get me the 2a squared I needed here. 2 times just a, or 1a, some people like to put the 1a there, would help there. And then 2 times what is 112? And if you don't know that, if you don't know what 2 times what is 112, you can always just grab your calculator and do 112 divided by 2. And that will tell you what that is. So it looks like 56 times 2 is 112. And because it's a minus, it's going to be minus 56. And so what we just did there is we GCF factored a 2 out front. We just said we could divide out a 2 out of all of that. But what's going to be different today is we're not done now, because we've learned how to factor a trinomial like this, well, at least we've seen it was possible, into 2 binomials. So that 2 is just going to come down, but now I'm going to look at factoring this part right here into 2 separate trinomials. And what we talked about is, alright, well, if I want to make an a squared, we know that to make an a squared through multiplication, the first 2 parts of each term have to be an a. So that way a times a would give me the a squared. And then to figure out the numbers that go with that a, whether it's a plus 5 or a minus 7 or whatever, to figure out the numbers that go in these 2 spots, we could do a factor x. But when we do the factor x now, instead of using the 112 and the 2, we're going to use the negative 56 and the 1. You should know that this kind of factor x model only works if this is just a plain a squared. If we try to do it with the 2a squared, we'd have to have a 2a and an a, and it would mess up because we'd be doubling the term over here. So this factor x only works if it's a plain a squared or x squared. But now we go to our sheet and say, well, what numbers multiply to negative 56 and at the same time combine to give me a 1? And you can use your sheets and look at negative 56, and what you're going to find is if I had an 8 and I subtracted a 7, 8 minus 7 gives me a 1, and 8 times negative 7 gives me the negative 56. So that means my factors are a plus 8 and a minus 7. And so if I talked about, well, what's my final answer? This would be the multiplication problem that would lead me to this. If you actually try to do this multiplication problem, you could do it lots of ways. You could multiply this times this first, and then multiply that by this, or you could multiply these 2 first, and then multiply by the 2. But this is the multiplication problem that would lead me to that answer. It just combines both the things we talked about, and so if you can do both of those, then you certainly can do each part kind of separate. So let's just look at a couple more examples just to go through. Maybe we can go through them a little bit quicker, just to give you guys a couple in your notes. So again, directions are going to be factor. If you need to pause the video to catch up, that's the nice thing about having a video, you can pause it. We're going to factor 6n squared plus 36n plus 30. 6n squared plus 36n plus 30. Let's try to find the multiplication problem that would lead me to this. And it's going to look something like this in the end. And so we're going to start kind of the same way we started last time. We're going to look is there any common factor? Is there any number I could divide out of all of these parts? And if you look, 6 goes into 6, 6 goes into 36, and 6 goes into 30. So we could divide out or factor out a 6. And then we can think about what we'd have to multiply that 6 by to get back to all of this. We want this line to be the same as this line. And so we have to make sure that whatever we put here, that if I multiplied it, I would get these 3 terms back. So 6 times what gets me to 6n squared? I already have the 6, I'm just missing the n squared. So 6 times n squared would give me the 6n squared. Now we just keep moving to get to the 36n. And so I just asked myself that same question. 6 times what? What would have to go here for me to multiply the 6 to get a positive 36n? Well, 6 times 6 is 36. Now if I just left it like that, I would just get a 36 for an answer, but I need a 36n for an answer. So I need an n here so that when I multiply these, 6 times 6n is 36n. And then 6 times what is 30? That's going to be a positive 5. So that's the GCF factoring. Our greatest common factor in this case was the 6. And now we can look to see if maybe we can factor this again. Again, trinomials, that's 3 terms. N squared, 6n, and 5 is a quadratic trinomial. These can be factored into a binomial times binomial, or a 2-piece times another 2-piece. The nice thing is it's pretty easy to set up the first part to get an n squared. It's just an n and an n. N times n is n squared. And then if I want to get the rest of it, I'm going to have to do that factor x setup. Now when you set up your factor x, it's always this last number that goes on top, and it's always this number that goes on bottom, because what we need is 2 numbers that multiply to 5 that add to 6. And that's how all those factor x's that we practiced were set up, numbers that multiply to 5 that add to 6. There's not many numbers that multiply to 5. If you think about it, the only one I can think of is 1 and 5. If I put a 1 and 5 here, 1 times 5 is 5, and 1 plus 5 is 6. So this combination of numbers would work. So that means those are our factors, n plus 1 and n plus 5. Whatever, if this is positive, there would be pluses. If this is negatives, they would be minuses. They're positives. So this would be our final answer. Now, if I multiplied this back out, n times n would give me the n squared. N times 5 would give me 5n, and I'm supposed to have 6. But again, if I multiplied these two, I get my other n. So the 5n plus the 1n make the 6n, and then when I multiply the 1 times 5, it's 5. So it does work out. I can box this in because it's the right answer. And that's kind of the GCF factoring. It works the same way no matter kind of what, as long as there's a GCF. We are going to look eventually at ones that don't have GCFs, and there's different ways to do those. But for right now, we just want to practice ones that have GCFs. And so we can just see now that maybe if we don't talk as much, we can see how fast we can do these. You look at it and you're like, oh, they're all divisible by 5, so I'll divide out a 5. 5 times x squared is 5x squared. 5 times negative 8x is negative 40x. And if you don't know what 5 times what is 75, again, just go to your calculator and just reverse it. If you don't know what times 5 is 75, just divide it out, and you find out that it's a 15. So you can just put plus 15 here. Don't worry if you have to use a calc, that's totally fine. And now we're going to split this up into 2 binomials. X squared is an x times an x. And we need numbers that multiply to 15 that add to negative 8. And so if you set up your factor x, what happens on this one though is it's pretty easy to figure out numbers that multiply to 15, like 5 and 3, and it's close to adding up to 8. It adds up to positive 8, but we need it to add up to a negative 8. Now, I got to be careful because if I make this negative and I leave that positive, it no longer multiplies to a positive 15. The only way it would multiply to a positive 15 is if they're both negative, because a negative times a negative is a positive. Negative 5 minus 3 is a negative 8. And so that means that my answers are going to be x minus 5 and x minus 3. So when you guys get your work today, there's going to be some GCF 2 factor x's. Try your hand at them. I think I'm going to have the odd answers on there. Do the odds and evens. If you get stuck, just know that you're stuck and that you you'll need to ask on Friday when I get back. Other than that, good luck, and I'll see you tomorrow.